Hello and welcome to this example video where we're going to work on finding key information of rational functions. Now when I'm talking about key information, we're looking for the, let me do this in a different color here. We're either looking for our horizontal asymptotes, we're looking for our vertical asymptotes, and we're looking for zeros. So those are the big things that we're going to be looking for. And so let me walk through some examples and help you find these things. Okay, so first, let's talk about zeros. Zeros are when we take our numerator and we set that equal to 0. So in order to figure out what my 0 is going to be, I'm going to take 4x minus 8, set it equal to 0, and then I'm going to solve that equation. Adding 8 to both sides, I get 4x equals 8, and ultimately x equals 2. So that is my 0. Now if I want to look at my vertical asymptotes, so do a V right here. And then also we might consider these to be excluded values. These terms are loosely the same thing. So where the excluded values are where your where your vertical asymptotes will be. And so for that, what we do is we take our denominator and we set that equal to 0. So I'll have x squared minus 1 equals 0. I do some factoring, I get x plus 1, x minus 1, meaning that my vertical asymptote is going to be either at -1 or x equals positive 1. And notice the variable we have here. So these vertical asymptotes, these go to correspond to the graph. So if we were to draw a graph at -1 and positive 1, our graph is going to get really close to that, but never actually touch it. And so that's why it's an x equals, because it's a vertical line. Okay, now continuing on, we have to do the horizontal asymptote. So for the horizontal asymptote, we'll do this in yellow. It's all about taking a look at our leading terms. So currently I'm doing it in red. That's cool. So now notice how down here I have x squared. That is bigger. So if the degree in the denominator is greater than the degree in the numerator, that corresponds to my horizontal asymptote being y equals 0. All right, and really quickly, the reason why that is as I start putting in larger and larger numbers, so like 100, 1,000, 10 million, when you square that, that's going to get much bigger, much faster than timesing it by 4. And so as a result, you're constantly going to be dividing by a bigger and bigger number, and that's just going to get you closer and closer to 0. Okay, but the main thing is to take a look at it and look at the degree, and that tells you a lot of information. Okay, next, let's take a look at the this next one right here. So again, what we want to do is we want to start off with our zeros. So I'm going to look at my numerator, 5x squared minus 20, set that equal to 0. Actually, what I'm seeing here is I can take out a 5 to get x squared minus 4 is equal to 0. Factor this as a difference of squares. And so my zeros are x equals 2 or at -2. Now for my vertical asymptotes / excluded values, I'm going to do something similar where I'm going to take x squared plus 7x plus 10, set that equal to 0. Since this is a quadratic, I now need to use those quadratic skills. So x plus 5, and then, what is it? Oh, plus 2. And so, let's see here, we're going to have x equals -5, x equals -2. The fact that -2, oops, thought I was doing this in yellow. The fact that -2 shows up in both is something interesting. That's going to be called a removable discontinuity, but that's a concept for another time. Right now, we're focusing on just finding these things. All right, and then finally, let's talk about my horizontal asymptote. So again, I'm going to analyze this. Now the horizontal asymptote, it's always going to be a y equals something. Well, actually 2/3 of the time, it'll be a y equals something. But now I'm seeing the exact same exponent here. And what that means is that these are matching up. These are on the same level. They're both squareds. So what I do is I take the ratio of the coefficients, which is just 5x. Oops, not 5x, just 5, sorry, 5. And so that's going to be my horizontal asymptote at the line y equals 5. All right, do a couple more. So let's take a look at this one. For the zeros, this one's going to be interesting here. I'm going to set my denominator equal to 0. But the thing is, there's no variable here, so it can't be done. So my answer is actually just going to be none. There's no value in here that's going to make this equal to 0. That's cool. All right, so for vertical, again, what we're going to do, and our excluded values, I'm going to take the denominator, set that equal to 0, see what happens. Here, I'm going to factor out a common term of x. So I have x times the quantity x plus 3 is equal to 0. And so that's x equals 0, x equals negative 3. And then finally, for my horizontal asymptotes, again, I'm going to take a look at what I have. And here, I don't have anything. In my numerator, and my denominator is clearly larger. And so again, if the denominator is greater than the numerator, what that means is that it's going to be at y equals 0. Now, hypothetically speaking, let's just say we flipped things around to where we're looking at x squared plus 3x all over 4. Well, what that does is that changes these guys. So I'll have no excluded values, and as a result, I'm going to have 2 zeros at x equals 3 and x equals negative 3, and then I'm going to have, for my horizontal asymptote, it'd be none. There's nothing that's bounding this. It's going to go on forever and ever in a certain direction. So you could also say plus or minus infinity. Again, maybe a little bit later we can get into more detail about what I mean by plus or minus there. But anyways, that's sort of just the read you have to make. So it's all about looking at the leading term. Finally, let's look at this. This is a fun one, right? But here, this is just to highlight something. So if we're looking for our zeros, all we're going to do is take a look at our numerator and each one of these terms and turn that into a 0. So it's going to be at negative 2, positive 5, and negative 3. There are our zeros. As for our excluded values or vertical asymptotes, we're going to do the same thing with our denominators. So this is an x equals negative 1, x equals 8, or x equals 4. And then finally, for the horizontal asymptote, what we're going to do is take a look at the leading terms. Now here, it's in factored form. But the thing is, if I bring these together, I'm going to get x cubed. If I bring these together, I'm going to get x cubed. And so all I really care about is the coefficients next to them, which are these two numbers right here. So now, since they're both x cubed, I just take that ratio, 6 over 15, which is equal to 3 over 5. And that's my horizontal asymptote. So hopefully these examples have helped kind of walk you through how to find these values. I tried to give you several different looks, several different explanations for kind of how to go about it. But let me know if you have any other questions. In the meantime, good luck with your practice.